Good day to all. Today we can discuss about a problem in how to solve and find the Q points for a biasing circuit. The subject analog circuits. So it is a gate question. So the given circuit is a voltage divider biasing, and it is asked to and it is given with the current gain beta is 125 and is asked to find the Q point ICQ and VCEQ. So to find your ICEQ and VCEQ, so first we can simplify this circuit as it is a voltage divider biasing circuit. So first and foremost step is we can find your VTH and RTH. So VTH is nothing but the total supply voltage, that is 24 volt, into across the resistance 42 by 42 plus 58. So it is nothing but 10.08 volt. Similarly, we can find the RTH, which is nothing but R1 R2 by R1 plus R2. It is a parallel circuit. So it is 58 into 42 divided by 58 plus 42. It is nothing but 24.36 kilo ohm. Okay, so these two five things we have found out. So we have to find the Q points VCEQ and ICQ. So first we can find ICQ. So to find your ICQ, so first we can redraw the circuit with the obtained values. So we have found VTH, RTH. So it is, so this VTH or total voltage is 10.08 volt and the resistance RTH is 24.36 kilo ohm with the transistor, and the total supply voltage is 24 volt, and you have the emitter resistance is 10 kilo ohms. Here the potential across this is considered to be VBS 0.7 volt, and the potential across this is considered to be the VCE. So first we can apply KVL to the base emitter loop. That means this loop, base emitter loop. So applying KVL to this base emitter loop, so total 10.08, that is the potential rise minus the potential drop across the resistance is 24.36 kilo ohm. That is, we can make it as 24.36 alone into the current across through this is IB. So it is IB minus VBE, which is 0.7, minus the drop across this collector resistance, the emitter resistance. The current is IE. So IE into the resistance is 10 ohm, which is equal to 0. But we know that IE is equal to 1 plus beta into IB. So we can replace this IE as 1 plus beta is 125 into IB. So IE equal to 126 IB. So it is nothing but 10.08 minus 0.7. It becomes 9.38 minus 24.36 IB minus 126 into 10 IB equal to 0. So you will be getting 1284.36 IB (9.38) minus equal to 0. From this, we have obtained the IB value as 0.007332 which we can denote it as IB as 7.303 microampere. So from this, we can able to obtain the value of IC as, but the relationship between IB and IC is beta IB. So it is 125 into 7.303 microampere. So it will be getting IC as 0.9129 milliampere. So we have found out ICQ, the first goal. Second thing is we need to find VCE. So to find VCE, apply KVL across the collector emitter loop. So across the collector emitter loop means this one. So 24 minus VCE minus the drop across this. So it is nothing but 24 minus VCE minus the drop across this. That is nothing but IE into 10 equal to 0. So 24 minus VCE minus 1 plus beta IB. IBS into 10 equal to 0. So 24 minus VCE minus 1 plus beta into IB is 126 into 10 into 7.303 microampere equal to 0. So from this VCE is 24 minus solving this you will be getting some 9.2. So your VCE is equal to 14.8 volts. So you have found out your second thing. So we have found out the IC as 0.9129 milliampere and VCE as 14.8 volt. These two are the Q points. So hope you have understand this. Thank you.